Hello everyone, good evening, good evening, good evening. I hope everyone is ekdam badhiya, ekdam mast, ekdam dhinchak. I hope you all are doing really well. And my dear NSEJS aspirant, I am sure most of you are having your school exams nowadays, but still the jazba should be on, the spirit should be high, because that is what is going to make all the difference. When all other students are only focusing on their board exam, you are thinking, you are targeting, you are also preparing for something bigger and better, that is Junior Science Olympiad. Of course, I'm sure you are going to do really well in your school exam, but yes, the show must go on, the preparation must go on. Good evening, Sonak. I hope everyone. Hi, Rahul. Good evening. So, here I am with another session of B2A series, that is basic to advanced series, where we are studying all the important topics for physics, chemistry and biology for our very own Junior Science Olympiad, right? Yes, and I'm sure those who are going to give Junior Science Olympiad in 2025, those who are science lover, they are already decided upon that yes, they want to crack this exam. That is why the preparation is on. Yes, so Joe should be high. Good evening, everyone. So without wasting much time, let's move ahead with today's session. So in the last session, I'm sure you remember, we talk about the discovery of subatomic particles, electron, proton, neutrons, and also we talk about the initial atomic models. What was they? Thomson's plum pudding model or watermelon model, and another one was important model, Rutherford's alpha scattering experiment. So let me tell you guys, the Rutherford's alpha scattering experiment is an important, very important topic as far as your exam is concerned, right? So just make sure, if you're really serious, you want to crack the exam, you should also know what all are the important topics for your Junior Science Olympiad, right? So before moving ahead, and I have already told you why our last model, Rutherford's atomic model, failed. We'll continue our story ahead, of course, in this session. But guys, let's know some basic terms, because already now you are aware of electron, proton, neutrons. They are the subatomic particles which are present inside an atom. Let us talk about some basic terms, and I'm sure you must be aware of these basic terms. And please tell me in the chat box whether you know these terms. Yo or no. You should write yo or no, right guys? Yes, in the chat box, yo or no. Okay, let us define atomic number. What is atomic number? Atomic number, that is represented by Z. So atomic number, is it visible guys? Is it visible? This video is clear guys? Yes. So atomic number, what is atomic number? Atomic number represented by Z. Yes, atomic number is represented by Z. What is atomic number? The number of protons in an atom. The number of protons are the positive particles. So the number of protons in an atom is known as its atomic number. Okay, I have changed the color of the pen. Still, I think there is some issue. Yes, just give me a second. Let me fix the issue if I can. I hope it is fine now. You're clear? Perfecto. So, atomic number, that is represented by Z, is the number of protons in an atom. So, if I say the atomic number of nitrogen is 7, that means atom has 7 protons. And if the atom is neutral, so that means atomic number can also be defined as the number of electrons in a neutral atom. Atom is neutral, so positive and negative charge has to be equal. So atomic number can also be defined as the number of electrons in a neutral atom, right? Now let us talk about the next term, that is mass number. What is mass number? Mass number is represented by A, right? A is the symbol for mass number. Now what is mass number? It is the sum of neutrons plus protons. That means it is equal to the number of nucleons, right? Nucleons is neutrons plus protons. So that is your mass number, right? Yes. So for example, I have some element whose symbol is X, right? In the foot, I will write its atomic number, that is Z. On the head, I will write its mass number, that is A. For example, I have helium atom. You all know the symbol for helium is He, he, right? So 2 is the atomic number, that is the number of protons in helium, and 4 is the mass number, that is the number of protons plus neutrons. Yes? Got it? So if I ask you in helium, how many electrons, protons and neutrons are there? What will be your answer, guys? So ma'am, protons indeed is 2, that is atomic number, and hence because it is a neutral atom, so electron must be 2. And neutron, so how can you calculate the number of neutrons? Mass number minus atomic number will give the number of neutrons, right? So the mass number is 4, atomic number is 2, so mass number, that is A minus Z, will give you the number of neutrons. I hope you are clear with it. Yes? 2, 2, 2. JEE Hustler, not 0, bache. It's 2 electron, 2 proton, 2 neutron. Got it? Yes? So very well done, those who got it. Let me ask you some more examples. Suppose I have sodium. Sodium, the symbol is Na. 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 Atomic number is 11. Mass number is 23. Can you quickly tell me how many electrons, protons and neutrons are there in sodium atom? So one sodium atom has number of proton is equal to atomic number. Number of electron is also equal to 11 because protons are positive particles, electrons are negative particles. Because it is a neutral atom, so they has to be equal. And number of neutrons, 23, that is the mass number, minus atomic number, that is 12. Got it? Yes, those who got this the same, very well done. Okay, now let me ask you about ions. So ions are of two types, right? One is positively charged ion, we call them cation, which is formed by the loss of electron, right? If electron is being removed from the atom, we got an overall positive charge on an atom, which was initially neutral. So we got a cation. And another type of ion which has a negative charge, because of extra electron is added, that is known as anion. For example, sodium positive is a cation. Chloride ion is anion, right? Electrons, one electron is removed from sodium atom, one extra electron is added to chlorine atom, right? Cation and anion. I'm sure you all are aware of this pretty basic term, right? So now let us quickly, guys, see how can we calculate the number of electron, protons and neutrons in ions. So suppose I have magnesium ion, magnesium 2 positive. Atomic number of magnesium is 12. Mass number is 14. Can you please tell me electron, proton and neutron in magnesium ion? So guys, proton is 12. That is equal to the atomic number Z. Because now it is an ion, 2 electrons are removed. So ideally, if it is a neutral atom, electron has to be equal to 12 only, right? But because it is a positive ion, so how many electrons I have here is 10. Because 2 electrons less, 2 electrons are removed, that is why it is having 2 positive charge. So 12 minus 2, you'll get 10 electrons are left. And how many neutrons? Neutrons same. Mass number minus atomic number, that is your number of neutrons. Got it? Okay, let us take another example of sulfide ion, right? So atomic number of sulfur is 16, mass number is 32. Please tell me how many electron, protons and neutrons are there in this ion. Yes, sulfur 2 negative. So to extra electron, sulfur is a neutral atom. If I add to extra electron to it, it will become sulfur 2 negative, right? So number of protons is equal to 16. That is the atomic number. So the number of protons in one sulfur atom is 16. And electron, now electron has to be 16 if it is neutral, but sulfur 2 negative, that means 2 extra electrons are added. That means it has to be 16 plus 2, that is 18, right? And number of neutrons, again, mass number 32 minus atomic number, that is 16, will get 16, right? So you should know what is atomic number, what is mass number, how many electron, proton, neutrons are there. And let me tell you one interesting fact about it. What is that? So not long back, in the final stage of Junior Science Olympiad, that is International Junior Science Olympiad, IJS, so one entire question was based on calculation of number of electron, proton and neutron in different ions, right? So that was one of the question which was not just asked in NSEJS, but recently in IJS also. Yes, study and music streaming. Okay. Now, next important terms. How many of you are aware of isotopes? What are isotopes? Isotopes are those species having, iso means same atomic number, but different mass number. They are known as isotopes. For example, I have hydrogen, atomic number 1, mass number 1. Another isotope of hydrogen, that is known as deuterium. This is protium. This is deuterium, mass number 2. Another isotope of hydrogen, atomic number is same because it is hydrogen, mass number is 3. So protium, deuterium, tritium, we have 3 isotopes of hydrogen. Same atomic number but different mass number, right? And out of 3, this is most unstable, radioactive, it decay, giving out harmful radiations. Got it, guys? Tritium. It's not terium. Genghis Khan, it is tritium. Protium, deuterium and tritium. 3 isotopes. So isotopes are those species which have same atomic number but different mass number. Now let us move on to the another term that is known as isobars. What are isobars? Can any one of you tell me what are isobars? Iso means same. Wherever we use iso, now that shows same. Isobars, yes. Isobars, what are isobars, guys? Isobars are those species having same mass number. Now the mass number is same but different atomic number. If atomic number is different, that means the atoms are of different element, right? Can any one of you give me the example of isobars? Those who are watching it live, let's see how many of you can give me the example. Any example you want to give, you can give. So the most common, let's take argon and our own calcium. Argon, you know, atomic number 18, calcium 20. Both have same mass number. They are different elements altogether. Yes, they are different elements altogether, argon and calcium. Right? So they are known as, very good, right to gaming. Well done, done. So they are isobars. What are they? They are known as isobars. Yep. Now, next term is isotones. Isotones. Can any one of you tell me what are isotones? What is same? Isotones. What is same in them? Isotones. Isotones. What are isotones? Isotones are those species having, what is the same there? Having same number of neutrons. Having the same number of neutrons. Can anyone give me example? Let's see. Same neutron number, same. Yes, number of neutron is same. Okay, so right to gaming is saying Na, that is sodium. What is another element? M, which is element M? Yes, new isotones. Okay, let me take example of sodium as, right, mass number 23, atomic number 11. And let me take example of magnesium, atomic number 12, mass number 24. Now, how many neutrons each of them is having? Number of neutrons present in each of them. And I hope I just told you neutrons is mass number minus atomic number. How to calculate neutrons? Number of neutrons is mass number minus atomic number. Yes, both of them has 12 neutrons. So if the number of neutrons is same, that makes them what? Isotones. So they are known as isotones, right? Yes. Perfect. Good going, guys. Good going. I can see the right answers coming in. Perfect. So now I have another term. Isosters. Isosters. So I am having two molecules, right? Yes. These are the two molecules. Can you please tell me how many atoms are there in N2 molecule? How many atoms are there in N2 molecules? Yes. So N2 has two atoms. One molecule N2 has two nitrogen atoms. It also has two atoms. Okay, great. How many electrons are there in N2? So nitrogen atomic number is 7. In one nitrogen atom, we have 7 electrons. We have two nitrogen atoms, so that means the total number of electrons is 14. Agreed. So N2 molecule has 14 electrons in total. Okay, now can you please tell me how many electrons are there in CO? How many electrons are there in CO? Carbon has 6 electrons, oxygen has 8 electrons, right? Atomic number of carbon is 6, oxygen is 8. So total the number of electrons is 14. So those species having same number of atoms and having same electrons, that means isosters are also isoelectronic, same number of electron. Very important term, ding, 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 isoelectronic. It is so very important that all the exams that you are going to give from now onwards, a good competitive exam till your JEE or whatever exam you are going to give, they all will ask you question on isoelectronic species. Isoelectronic species means having same number of electrons. So I can say N2 and CO, they are also isoelectronic, having the same number of electron. Got it, guys? And why I'm calling them isosters also? Because they have the same number of atoms as well as same number of electrons. Yes? Done? Now one more term, that is isodiphers. So this one term you will tell me in the comment section of the video. What are isodiphers? They are not diaper. Please mind it. They are not baby diapers. They are isodiphers, right? So what are isodiphers? So Jatin is asking me, ma'am, what are valence electrons? So valence electrons are the electrons present in the outermost shell of an atom. Please keep on attending the sessions here. We'll be doing all these things because for this to know how many valence electrons are there, we should know how to write the electronic configurations, right? How the electrons are arranged in an atom. Okay, so Sonak and Aditya and Jatin. Oh, very good. So isodiphers are those species which has the same difference in neutrons and protons. So neutron minus the number of proton should be same. Got it? Very right. Those who gave me the answer right away. You spoiled the homework for all other students, right? Okay, guys. So these are the terms that you should definitely know, right? So Now let's move ahead. According to Rutherford, how the atoms look like? According to Rutherford, as per Rutherford, the atom, how the atom looks like? There is a small positively charged center in which protons and neutrons are there and electrons are revolving around that nucleus. That is what Rutherford told us about the atom. Agreed? Yes? Done? And Maxwell proved that if electron, which is an electrically charged particle, will accelerate or will rotate around that nucleus, so this moving electron will lose energy in the form of radiations, and ultimately the electron will lose all its energy and it will fall into the nucleus and your atom will collapse. So Maxwell said, hence proved your atom is not stable, Mr. Rutherford. Come again. Yes? Come again. So, because of Maxwell was a famous physicist, right? He has a very famous theory in physics, that is theory of EM waves, electromagnetic radiations, right? So now I'm going to give you a little bit of idea about what are electromagnetic radiations. So what are EM waves? Electromagnetic radiations, as the name suggests, they are the waves. Wave is just a way by which energy travels. It is a disturbance, right? So it is a form of energy propagation, right? So electromagnetic radiations are those radiations which have oscillating electric and magnetic field, right? So you can see, if the wave is moving in this direction, this is the direction of movement of wave, so the electric and magnetic field associated with this wave, they are mutually perpendicular. So wave is moving in this direction, your wave is moving in this direction, and it has electric and magnetic field associated with, which are the three are mutually perpendicular, right? So the electromagnetic radiations are those radiations which have electric and magnetic field associated with them, right? You can see. Yes. Now the characteristics of a wave. How can we define the various characteristics of a wave? First is wavelength, which is represented by lambda. Very important term, lambda, that is wavelength. So we represent a wave like this. So I'm going to tell you about lambda. So what is one wave? One crest, one trough. This is my one wave. I show waves like this. So this is my one wave. If I ask you draw one wave, what you will say? This is the one wave, right? So the length of this one wave is known as wavelength, that is lambda. So units should be meter, centimeter, the units Armstrong, nanometer, any unit in which you can express your length, that is the unit, right? Jatin is asking, ma'am, please repeat, what are electromagnetic radiations or electromagnetic waves? So beta, the waves which are having oscillating electric and magnetic field associated with them, right? They have electric and magnetic field which are associated with them. They are known as electromagnetic radiations, right? Microwaves, X-rays, ultraviolet rays, visible light, they all are examples of these kind of radiations which are known as electromagnetic radiations, right? Yes? Done? So what is wavelength? The length of one wave. Wavelength. Got it, guys? Lambda. We represented it by lambda. Next property is frequency. So wave is passing, right? So what is frequency of a wave, which is represented by mu? What is frequency of a wave, guys? Please notice. What is the frequency of a wave? So what is the frequency? This is a point, right? I fixed a point. In 1 second, how many waves pass through this point? Per second. That is known as frequency of a wave. Wave is moving, going. So I fixed a point. So from this point, how many waves passed in 1 second? That is known as frequency of the wave. Got it, guys? Yes. Frequency of the wave represented by mu. Yep. So what are the units? Second inverse per second, that is, or hertz. Hertz is the unit, SI unit we call, that is equal to second inverse of frequency of the wave. Yes, done. Next important term, amplitude, the height of the wave or the depth of the wave, right? So this height, this is the mean position, how high it is or how deep it is, that is known as the amplitude of the wave. The height of the crest, this is crest, and the depth of the trough, both should be equal for a wave, that is known as amplitude, denoted by A. Yes, amplitude of the wave. Yes, Bholu. Eligibility depends upon DOB along with the class. So guys, if you are in class 8th, 9th or 10th in the upcoming session, that means in 2025 and 25-26 academic session, and you are 2011 or 2012 born, then yes, you can give NSEJS exam, right? Yes. Now the wave number. So what is wave number? Wave number is represented by mu bar. It is the reciprocal of wavelength. Yes, wavelength. That is wave number. So basically the unit of wave number is centimeter inverse, meter inverse, because it is the reciprocal of lambda, or how we can define. So it is the number of wave in 1 unit length. So if I have 1 centimeter, right? How many waves are there in 1 centimeter? That is known as wave number. Yes. So you should all know wave number is equal to 1 by lambda. Got it, guys? Yes. So you should know what is wavelength, what is frequency of a wave, what is amplitude of a wave, and what is wave number. Those who are 2010 born, Siddharth Agarwal, beta, you are not eligible to give NSEJS this year. You were eligible last year, 2024. Sorry, but you are not eligible this year, right? Now, one important relation that you should all know. The relation between frequency of a wave and wavelength. Very important relation. Frequency of a wave is equal to C by lambda. C is the speed of light. Light is also electromagnetic EM radiation. Light is also electromagnetic radiation. All EM radiation, they all travel with the same speed in vacuum. What is the speed of light? Can anyone quickly tell me what is the speed of light? Yes, quickly, what is the speed of light? That is C. What is the speed of light? Let's see how many of you know the speed of light. What is the speed of light, guys? Very good. Siddharth is saying 3 into 10 to the power 8. What is the unit, Siddharth? Three into 10 to the power 8 meter per second, or I can say 3 lakh kilometers per second. So your wave can, the light, that is electromagnetic radiation, all electromagnetic radiation travel with the same speed, right? So the speed of your EM wave light is 3 into 10 to the power 8. So in this formula, C is fixed. That is speed of light. So this is frequency, this is wavelength. If you increase the wavelength, the frequency of the wave decreases. Wavelength is the lambai, the length. Right? Yes? Done? Okay, great, guys. So this relation about a wave, you should definitely be knowing. Yes, Aditya will be covering all the 3 subjects, that is physics, chemistry and biology in this series, B2A series, right? Basics to advance. So Tuesday is for chemistry, Thursday is for physics and Saturday is for biology. Thursday you'll have your physics session, right? Tuesday chemistry, Thursday your physics and Saturday will be having your biology. Chalo, let's move ahead, guys. Now these all are electromagnetic radiation, radio waves, microwave, infrared, visible light, ultraviolet, X-rays, gamma rays, right? So all these radiations, they are arranged according to their wavelength or frequency, right? Yes. So this is known as electromagnetic spectrum. Electromagnetic spectrum. So when the radiations are arranged according to their increasing wavelength or decreasing frequency, that is known as electromagnetic spectrum, right? So if you move from here to here, from gamma to radio waves, your lambda increases. If lambda increases, that means frequency decreases. So they all are electromagnetic radiation, guys. Please see, radio waves, microwaves, infrared, visible light, ultraviolet, X-rays and gamma rays. Initially, cosmic rays are also considered to be EM rays, electromagnetic rays, right? Yes, but now later the studies proved that they are not electromagnetic radiations, they are not waves. Perfecto? Yes. Done? Yes. So let's have a quick rapid fire round, right? Quick. So you have X-rays, you have visible light. X-rays and visible light, which has more wavelength? Quickly, let's see how many of you. So this is the order. If you gamma, X-ray, UV, visible, infra, the wavelength increases, the frequency decreases. As I already told you, mu is inversely proportional to lambda. Yes, without seeing the board, out of X-rays and visible light, which has more wavelength, I'm asking wavelength, guys. Let's see how many of you can answer me without looking the slide. More wavelength. Visible and so our visible light is also electromagnetic radiation, right? X-ray is also electromagnetic radiation. Which has more wavelength? Which has more wavelength? Out of visible and, I'm asking out of visible and X-rays. I'm asking out of visible and X-rays, which has more wavelength? So visible light has more wavelength, as I told you, from here to here. Lambda is increasing from gamma to X-rays, right? So if I have to write the order, the lowest wavelength gamma, then X-ray, then UV, then visible, then infrared, then microwaves, and then radio waves. Yes, so visible has more wavelength, or you can say less frequency than X-rays. Got it? Okay. Out of microwaves and ultraviolet rays. Microwaves are also EM waves, ultraviolet rays are also EM, which has more wavelength. Which has more wavelength, microwaves or UV rays? Which has more wavelength, microwaves or UV waves? Yes, microwaves have more wavelength than your UV ultraviolet rays. Yes, indeed, you can see the length is more, no? You can see it is more spreaded. Yes. So visible light, if I call visible light, visible region, visible light is also electromagnetic rays, right? Visible light. The colors that we can see, that is also VIBGYOR. That is also electromagnetic radiation. And in VIBGYOR, V stands for violet, indigo, blue, green, yellow, orange, red. and it is also according to, from violet to red if we move, wavelength increases. So if I ask you out of blue color and red color which has more wavelength, what you will say? Vibgyor. According, it is also increasing wavelength, right? Yes. Can you please tell me, blue or red, which color has more wavelength? More wavelength. The length of a wave is more in which color? It is red. Okay, quickly, green or orange, which has more wavelength? Green or orange, which has more wavelength? Green or orange, which has more wavelength? Orange. Orange has more wavelength. Indigo or yellow, which has more wavelength? Indigo or yellow, which has more wavelength? Yellow, yellow, dirty fellow. Yes. More wavelength, bole to less frequency. Yes. Got it? Perfecto. And 470 nanometer, the visible light, the visible colors, the wavelength lies between 470 to approximately 720 nanometers. And I hope you all know 1 nanometer is equal to 10 raised to power minus 9 meter. That is 1 nanometer. So with this, let me ask you the various units, right? So this is the range of wavelengths of visible light: violet, indigo, blue, green, yellow, orange, red. Now, quickly tell me. 1 micrometer is equal to 10 raised to power minus 6 meter, right? 1 millimeter is equal to 10 raised to power minus 3 meters. 1 centimeter is equal to 10 raised to power minus 2 meters, right? Now, these are commonly used. 1 nanometer is equal to 10 raised to power minus 9 meter. 1 angstrom, that is equal to 10 raised to power minus 10 meters. 1 picometer, that is equal to 10 raised to power minus 12 meter. They all are the units. 1 fermimeter, FM, that is equal to 10 raised to power minus 15 meters. 1 AM, autometer, is equal to 10 raised to power minus 18 meters. Right? Got it, guys? Yes or no? So you should all know, you should also know what is megameter, what is gigameter, kilometer, mega, giga. Yes? Perfecto? So you should all know these units: micrometer, millimeter, centimeter, nanometer, angstrom, picometer, fermimeter, or atometer. Done? Okay, so Vibgyor, visible light, that the light, the colors that we can see, they are also electromagnetic radiation. They all travel with the velocity or speed 3 into 10 raised to power 8 meters per second, right? We should know the relation between frequency and wavelength. We should know what is wave number. These all are the basic terms that you all should know. Yes? Okay, now electromagnetic radiations, we have all known now what are electromagnetic radiations, and Maxwell's theory was based on the electromagnetic radiation. They are about these electromagnetic radiation, but later on many points of electromagnetic radiation theory of Maxwell was proven wrong. Now you will see, you will feel, ma'am, if Maxwell's theory was also proven wrong, then maybe Rutherford model was correct, because of the Maxwell EM theory, Rutherford model failed. So if later on Maxwell theory failed itself, that it means, yes, it means that the Rutherford model might be correct. Isn't it, guys? What do you say, guys? So Rutherford atomic model failed because of Maxwell EM wave theory. Later on, Maxwell EM wave theory also proven wrong. Yes, right to gaming is saying, ma'am, both are wrong. Indeed. See, guys, Rutherford atomic model failed because of one point which was said in the EM theories, which was indeed a right point. Many other things were also there in EM wave theory by Maxwell. They were proven wrong later on. Yes. So Maxwell was the person who gave theory or certain, enlightenment about electromagnetic radiation like X-ray, microwave, radio wave, ultraviolet rays, visible light. Yes. Many points of his theory were proven wrong, and later on, the correct theory was given by Planck. That is the Planck's quantum theory. The theory is also about light. The theory is also about electromagnetic radiation, but Max Planck quantum theory was a right theory which came after Maxwell theory about electromagnetic radiation. So now we are going to do that, but because the theory is Max Planck's quantum theory, Planck quantum theory. So before understanding the theory, we should also understand the meaning of quantization. Do you know what is quantization? Yes. What do you mean by quantization? It is very interesting, beautiful term, quantization. I am not asking you the formula. You are telling me the formulas of Planck quantum theory. I am asking you, what is quantization? Quantization means having certain fixed or discrete values. Only these values are possible, right? So, if I, reach second floor by climbing stairs. So by climbing stairs, if a person reaches the second floor, and if I ask how many stairs you climb to reach this floor, the answer would be 2, 3, 4, 5, 6, 7. These are the values that are permissible, you can say. The person cannot say 2.5 stairs I climbed, or I climbed 3.6 stairs, right? So that means the question that I asked, that has certain fixed discrete values. Not every value is possible as an answer. So that is known as quantization. Having certain discrete values. So if I ask you in which year you are born, is it quantized or not quantized? In which year you are born? Is it quantized or not quantized? Does it have a certain discrete value? It can have any value. Can the answer be, ma'am, I was born in 2010.8 or 2011.6? No, the answer has a certain discrete value. You can't say I was born in my 18th century, 1810. Only certain fixed values are possible. Your answer can be 2006, 2007, 2008, 2009, 2010, 2000. There are certain values. Your answer cannot be, ma'am, 2006.3. Maths made easy, please listen carefully what I am saying. Rather spamming with not understood, try to understand what I am saying. I am giving more examples, right? Got it? So if I ask you, how many siblings do you have? If I ask you how many siblings you have, your brothers, sisters, is it a quantized value or not? The number of siblings you have is quantized or not? The number of siblings you have is quantized or not? Does it have certain discrete values? Yes, Puneet. I will see to that, Puneet. Yes, it is a quantized value. It can have only certain values, 2, 3, 4, 5. You cannot say, ma'am, I have 10.9 or 10 or 11.3 siblings, right? So there are certain fixed values which are allowed as an answer for this. Got it? Yes. Okay. My favorite example, I always ask when I talk about a quantization, right? So listen, you have a cake, your favorite flavor, right? Any flavor that you love. Which is your favorite flavor? Write in the chat box. Which is the favorite flavor of cake? Your favorite cake flavor. So you have a cake. Your favorite flavor cake. Chocolate, strawberry, vanilla, butterscotch, red velvet, any flavor, hazelnut, any flavor you want. So my question is, number of pieces in which this cake can be cut. Number of pieces of cake, or you can say the number of pieces in which the cake can be cut. You have a cake, the number of pieces in which you can cut the cake is quantized or not. The number of pieces in which you can cut your favorite cake is quantized or not. Does it have a certain fixed value? You can cut this cake into 1, 2, 3, 4, 5 pieces, or you can also cut it into like 2.5 pieces, or the number of pieces in which you can cut your favorite cake is quantized or not. Okay. Yes, please. Not quantized, not quantized, not quantized. Okay. Can you cut this cake in 2.5 pieces? Can you cut this cake in 2.5 pieces, guys? Can you cut this cake in 2.5 pieces? Yes or no? Can you cut this cake in 2.5 pieces? Number of pieces 2.5. Those who can cut, they are a god. Because I am not able to do that. How can you cut a cake in 2.5 pieces? Ma'am, 2 equal pieces, 1 small piece. Is it what you are saying? Is it what you are saying? So 2, ma'am, bigger pieces, and third piece is half of those 2 pieces. 2.5 pieces, yes? My dear lovely kids, even if you cut 2 big pieces and 1 half piece, that itself means you have 3 pieces of cake. That is not 2.5 pieces. Number of pieces 3. 1, 2, 3. Yes? Are you getting my point? Because most of you fell into the trap. That is why it is my favorite analogy. So, you cut this cake 2 equal pieces, 1 half small piece. That also it means it has 3 pieces. You cut the cake in 3 pieces. You cannot cut your cake in 2.5 pieces. The number of pieces will be 3. Yes, that is quantization. So the number of pieces in which you can cut your cake is also a quantized value. It cannot be 2.5 pieces. Yes, either it is 2, 3, 4, 5 and so on. Got it, guys? Yes or no? Bingo. Yo, please write yo in the chat box if you got it. So quantization or comes from the word quantized. Quantized means having certain discrete value, right? So only certain values are possible. Yes, got it? That is the quantization. And our Planck used the word quantization in his theory. That is the Planck's quantization theory, right? So according to Planck, suppose if a source or a body, so this is some source or a body from which the radiations are emitting out, coming out, and these radiations are electromagnetic radiation. What kind of rays are these? Waves are these? Electromagnetic radiations. Yes. So according to Planck, you are thinking they are continuous. No, Planck change सारी भावनाएं, जज्बात बदल दिए, भावनाएं बदल दी. How? He said these electromagnetic radiations, they have small packets of energy. It is not a continuous, it is discontinuous. Break in between. Packet. Right? So one packet of this has energy. So these are the energy packets in every radiation. They are known as quanta. So what are quantas? They are the packets of energy in the radiation. So the light which is falling on me, it has small packets of energy, and that is quanta. In case of visible light, we call this quanta as photon. I am sure you have heard the term photon. So photon is basically a quanta of visible light. Visible light is also electromagnetic radiation. Yes. So according to Planck, the electromagnetic radiation, X-rays, ultraviolet rays, UV rays, all they have discontinuous nature. They have small packets of energy known as quantas, right? Yes, they are not continuous. Maxwell told in his theory it was continuous. He was only considering this breakdowns, the wave motion, right? Planck said no, it is not this continuously they are coming. They are coming in the form of small packets of energy. They are known as quantas. So all quantas belong to same radiation. all packets have same energy, right? And the energy of one quanta, the energy in one packet of the radiation depends upon the frequency of the light. More is the frequency of radiation, more is the energy in one packet. Yes? Perfecto? Yo? So, according to Planck, Planck said the energy of one packet, one quanta is directly proportional to the frequency of radiation. If you want to increase the energy of one packet, one quanta, increase the frequency of radiation. Yes? And E is directly proportional to mu. To remove the proportionality sign, we have one constant that is known as Planck's constant. H is a constant that is known as the Planck's constant. Can any one of you know the value of Planck's constant? What is the value of Planck's constant? So you should remember the value of Planck's constant, joule second, right? 6.63 into 10 to the power minus 34 joule second. It is a constant. Yes, that is Planck's constant. 6.63 into 10 to the power minus 34 joule second. Done? Yes. So that is Planck's constant. So energy of one quanta, one packet of radiation is equal to H into nu. This is very important formula, guys, right? Suppose you have n packets in the energy. Total, I have n number of packets in the radiation. So the total energy of radiation is E is equal to NH nu. And what is N? Number of packets, number of quantas in radiation. Right? Yes. One packet has H nu energy and each packet of a radiation has equal energy. And I have n packets. So simple basic math says the total energy is NH nu. Right? So what is the possible value of N? It can be 1, 2, 3, 4. The N value can be 1, 2, 3, 4. It cannot be fractional. 1.2, 1.5. No, it is not possible. 2.3 packets. No. The number of packets in a radiation, that has to be a whole number. Yes. Yes. So if N value is fixed, N cannot have any value. N can only be 1, 2, 3, 4, 5, 6. So number of the N value is fixed. Can I say if N value is fixed, E value is also fixed? That is also quantized, certain values are possible. 0 means no radiation, no quanta. Yes. Can I say if N has only certain values possible, that implies that E should also have certain possible values. It cannot have any value. So that is quantization of energy. The energy of radiation can only have certain values. Not any values possible for energy of radiation. This is the feeling of Planck quantum theory, quantization. According to Planck, electromagnetic radiation, this light, not all energy values are possible. So light can have only certain energy value. The energy of light is only certain values. Not any value or every value is possible. Got it? That is Planck's quantum theory. Quantization, a beautiful concept that will take it forward in all other theories also ahead. You should know what do you mean by quantization, having certain discrete values. So this is very important formula given by Planck. Yes. So Planck's quantum theory talk about the electromagnetic radiation. They are discontinuous nature. They have small packets of energy known as quantas. The energy of quanta is directly proportional to the frequency of radiation, and that is equal to E is equal to H nu. And if you have n quantas, that means the total energy of the radiation is E n H nu. And we can also write, because frequency is C by lambda, we can also write it like this. So these are the two very most important formulas that you should keep in mind from Planck's quantum theory. Got it, guys? Very important. In class 11th also, NCERT also, back exercise has so many questions on these formulas. E is the energy of radiation, electromagnetic radiation. N is the number of quantas, or if it is a visible light, we call quanta as photon. H is Planck's constant, having a constant value. Nu is the frequency, lambda is the wavelength, and C is the speed of light. Got it, guys? Yes, perfect. Done? Yes. So this means the energy can have value 0 h nu, 2 h nu, 3 h nu. Got it, guys? I have told you everything. The value of h in joule per second, kilojoule per second, erg. Erg is also unit of energy in CGS system. Yes. Done? So quickly answer me. This is the question that was there in your class 11th NCERT. Vivid Bharati station of All India Radio broadcast a frequency of 1500 kilohertz. Frequency is given, wavelength they are asking you. Quickly, let's see how many of you can answer me this class 11th NCERT question. So, mu is given to you C by lambda. Right? Mu is 15 kilohertz. So, I am converting it into hertz. Kilo, right? So, this is hertz. C is speed of light, 3 into 10 raised to power 8 upon lambda. Got it, guys? Yups. Done? Perfecto? So what should be the answer? Quickly let me know the answer. Simply putting the values, you will get answer if you don't do any calculation mistake, right? Yes, so the answer indeed is lambda is equal to, please check your answer. Please don't do any this direct application of formula. Please see 200 meters. Yes, those who are giving 200 meter, well done. Next, what is the frequency of photon? Now wavelength is given in Armstrong. Convert it into meter, guys. Make sure that units are correctly used. So now lambda is given and they are asking you frequency. Mu is equal to C, that is 3 into 10 raised to power 8 meter per second. So lambda also should be in meters. What is the value of frequency? Wavelength is given and they are asking you frequency. Let me know quickly. Let's see without making any mistake. Simple basic calculation. What should be the answer, guys? Mu is equal to C by lambda. Indeed, the answer is, yes, guys, what is the answer? Is it A or C? Simple calculation, guys. 3 by 4. Yes, the answer indeed is A. Please do the calculations correctly because in the first stage of Junior Science Olympiad, that is NSEJS, calculators are not allowed. And I'm sure my kids can do this much of calculation without making any mistake. So the indeed answer is A. So we are done for today, guys. We studied about the important terms, the electromagnetic radiations, the Planck quantum theory, and we'll move ahead with more interesting topics. Photoelectric effect. Very important, very interesting, important for Junior Science Olympiad, important for Chemistry Olympiad, important for JEE, important for NEET. Photoelectric effect, PEE, right? So that's all for today, guys. And we are having our NSEJS Prime batch, which is running. We started with the batch. If you want to be a part of this batch, a program which can enhance your performance, which can enhance your love for science, also targeting Junior Science Olympiad. This is the batch for you guys. Live sessions, regular mentorship, assignments, regular testing, all in all care. You are just supposed to attend the classes, nothing else you're supposed to do other than solving, of course. So this is the batch. You can, See the link, batch link in the description box. So if you want to be the part of batch, use code NPR Pro so that you can get this batch in 6,999, guys. Yes, already the batch is going on. Hurry up, guys. If you're serious about cracking NSEJS exam, one of the most prestigious exam, if you want to have that tag with you that I am NSEJS qualifier, I am among top 300 students in India in science. So this is the batch. You should have a full-fledged, preparation for the exam, right? Yes. Yes. Okay. Great, guys. That's all. Yes. Maths made easy. Just study and crack the exam from wherever you want to. Yes, if you are a science lover, I can see in you're a maths lover, right? So if you are also science lover, just study from wherever you want and evolve that love for science and maths. And I'm sure you're going to help country and nation to grow more and more with your knowledge, right? That's all I can say. What is the timing? So right to gaming, Tuesdays for chemistry, Thursdays for physics, and Saturdays for biology. Time is 8 to 9 p.m. Monday, Thursday, Saturday, 8 to 9 p.m. on this channel. You'll be studying science, more detail, more depth beyond your school curriculum for Junior Science Olympiad. Yes? Got it, guys? Math is not there. Jatin only study. It is the Science Olympiad. So you have science, physics, chemistry, biology. You have a separate Olympiad for maths now. Initially, before 3 years back, maths were also there in Junior Science Olympiad, but that is also very easy kind of maths, 9th class, 10th class standard maths, right? Way easy than the science. Yes, but because we have a separate Olympiad for maths, why to need maths in this indirect question? The maths we need for physics, the maths we need for physical chemistry, that is the basic indirect maths is there, right? Yes. Any other doubt, guys? If you have any other doubt regarding the batch or Junior Science Olympiad, let me know. So the batch is running, guys. You can be a part of this batch. Yes. And if you want to contact me for any guidance, I am there for you all. Let me write my Telegram ID. This is my Telegram ID, NIDHI PRSHR. This is my Telegram ID. NIDHI PRSHR. This is my Telegram ID. You can contact me and yes, ask me anything you want to regarding chemistry preparation, Junior Science Olympiad preparation. I'm there. And please do not forget to join our Telegram group. There's a Telegram group dedicated for NSEJS 2025 aspirant. So you will get the link of that Telegram group in the video description box. Yes, video description box. You'll have a link. Join Vedantu NSEJS 2025 update group. Please join the Telegram group so that you can be connected with me and the cult of NSEJS, the students who are going to give NSEJS. You can interact with them. Okay, this is my Telegram ID and this is my email ID, nidhi.prashar@vedantu.com. Right? This is my Telegram ID. Right to gaming. That is a Yuvraj, that is a unit of length, angstrom. That is a unit of length. 1 angstrom is equal to 10⁻⁻10 meter. Meter is the SI unit. Anything else? Yes, guys. Anything else? If you want to ask me anything, most welcome. And in the end, I will just say, let's bring gold for India, guys. You are the future of India. Yes, let's take our country ahead of any other nation in the world, ahead in science, ahead in technology, and I'm sure the future is in right hands. The way you all are doing, you all are showing interest in the field of science, technology and maths, that is super amazing, right? And I'm sure the future is really bright for India. Bye guys, take care, God bless you all.